Hello, welcome back. The next talk is Rest Easy with Jupyrest, and will be presented with Koushik Krishnan. An applause, please.
Thank you. All right, good afternoon, everyone. My name is Koushik, and today we'll be resting easy with Jupyrest. We're going to be talking about Jupyter notebooks here. Raise your hand if you've used a Jupyter notebook. All right, great. Yes, we love notebooks here. So before I begin, I want to introduce you to a friend of mine. His name is Jupy. He's a mascot that I created for this project. It's the closest thing AI could make for Jupyrest. So that's what it thought about, Jupyter, and he's taking a rest. He's your friendly neighborhood, planet-scale app developer, and his code is so good that he never gets paged, and so he can sleep like this all the time. Okay, so about me, my name is Koushik. I am a site reliability engineer at Microsoft, but I like to call myself a code artisan, because code is art. And that's pretty much it. I'm going to be talking about a project that I worked on at Microsoft that it's now open source. So before I begin, I want to talk about this thing called serverless. It's a relatively new way of deploying web applications, and it's really cool because now, as a Python developer, you can just upload your code as is to somewhere and basically make a web application available to anyone on Earth, and someone else will take care of things like the scaling, the authentication, telemetry, alerting, monitoring, all these super annoying things. And it really makes Python so much more powerful and makes writing web services so much easier. But the problem is that I like to write code in Jupyter notebooks. For me, this is the superior development experience. It's better than Vim, it's better than Emacs. I mean, Jupyter Notebooks, it's the only place where your code can live alongside your documentation, and you can have charts, tables, widgets. It's really like a living document. I think it's just as approachable for experienced developers as it is for junior developers, so it's just totally awesome, and I think you all would agree with that. But the problem is that you can't just deploy a notebook. I mean, when you write a notebook, it kind of stays in this proof of concept, sort of prototype stage, and only when you actually want to make a product out of it, you have to rewrite it, and you lose a lot of the benefits of the notebook just by doing that. So that's why I created Jupyrest. So Jupyrest is a library to convert your Jupyter notebooks into REST APIs, Jupyrest. So I like to call these notebook functions. Basically, what the library lets you do is define some input and output contracts for every notebook, and then let you deploy it as a web service. So I developed this at Microsoft a few years ago, and it's open source, and now it's been in production since 2020 for a large number of our Azure teams. And this library lets you deploy fast API, Azure functions, and it can support pretty much any serverless cloud out there. So let's take a look into what this is. So what is a notebook function? A notebook function has three things. It's got a unique ID, an input schema, and an output schema. So very similar to any other kind of function. So if I were to take a standard Jupyter notebook like this and convert it into a notebook function, the first thing is I'm going to have to designate my input and output in my notebook. So the input here, I have to tag it with this code cell called parameters, and then the output is I just need to have somewhere in my notebook, I just need to call this save output function. So what this function is, you can kind of think of it like the return statement of your like a normal Python function, or maybe the response you would send in a fast API web application. So this is like some JSON you want to send back to the client. So you add those two things, and your notebook's pretty much good to go. The next thing you'll need to do is to include this configuration file, and it just needs to have the same name as a notebook. That's it. So here we're going to actually define those three things I talked about earlier. So the first is the ID, some unique identifier for this notebook function. The next is an input schema. So this is using your standard JSON schema spec if you've ever used OpenAPI or something like that. In this case, this notebook takes in a name, and the name is a string. The next section here, you got to define a output schema. So same thing, just what can the client expect as a response from your notebook function. That's pretty much it. And that's it. So when you have your Jupyrest library, you can set it up. You just basically give a path to your notebooks directory. But this is I'm not going to explain all this. Let's actually go into some demos where I can go deeper into how all this works. So what I've done is I have a notebook here that we're going to use just to go through how this works, because what better way than to show off notebook functions than with a notebook itself. All of this is on GitHub, by the way. It's including this demo notebook, so not to worry. I'm basically going to be using that Hello World notebook and showing what kind of things you can do with it. So the API, so we have a Jupyrest client that's part of the library, but it's a very simple Swagger API here, so you could use any HTTP client of your choice. But for here, we're basically just setting up the client, and I've got some helper functions here for displaying some things. So now that I have the client set up, the first thing I can do is I can just see what notebook functions are available. And these are just getting all those notebook IDs. I can get details about a particular notebook. So this notebook, this is that same Hello World notebook, and we can see our input schema and our output schema here. So I'm going to execute this notebook now. Now what I'm going to do is I'm going to actually execute it with an invalid schema. So you see here I've got foo. This should really be name here. So as any good API would do is that it would reject this request because the schema doesn't match. So you get that as part of this. So now let me actually send the right response. So I'm sending name and PyCon 2024 as the string. And so what this library is doing under the hood, it's actually injecting a new code cell into the notebook with my input parameters and then running the notebook from top to bottom. So when I run this notebook, I get a bunch of JSON here telling me some metadata about the execution. Here it is displayed a little bit better. So we can see the first artifact I get is an HTML of the notebook execution itself. We can see here that PyCon 2024 has been converted into a code cell in the notebook, and now my notebook has been run from top to bottom. The other thing I get is the output. So this is whatever I saved in that save output function, so that I can get that as JSON out. So I've effectively turned my notebook into a REST API because I'm sending JSON in and JSON out. But I also get the benefit of having a HTML of what my notebook function actually did. So any charts, tables, graphs, I can preserve all of that here, as well as get the more simplified, REST API experience. So there's a few other artifacts here. I guess I'll just talk about them. So the HTML report is the same thing as the HTML, but it has the code cells removed if you want to, if those are not relevant to you. So next what I'm going to do is I'm going to execute an erroneous notebook function. So as with any web service, we have to expect at some point a Python exception is going to be thrown in our code, and something's going to break. The client is going to get a 500. So what happens when we get that? Usually when you deploy, let's say, a fast API web application, we get some errors, and it's on me to go and dig through my logs, find out all the red text, and try to figure out what the heck happened and reproduce it on my laptop. With notebooks, it's way easier. So for example, this notebook execution has failed. Okay. And what I can do is I can see the HTML. So this alone helps me debug any failure in my notebook quite a bit. I can see where the exception was thrown, what code it was actually running, and this is without the need of any kind of telemetry or monitoring, or I don't need to worry about where my logs are stored. It's all in this notebook. The next thing is I get the actual I, Pi, and B as well. So this is the notebook JSON and of the executed notebook. And if I wanted to reproduce this on my laptop, I can download this and open it up in Jupyter Lab, and I'll effectively be able to run this whole notebook on my laptop. I don't have to figure out what parameters were in there or do any kind of correlation. It's all contained right in here. So it's kind of a benefit that you get just by using notebooks. You get a better debugging experience, a better editing experience, and you're able to, it just makes deploying and monitoring and developing web services that much easier. So this library, like I said, we've used it at Microsoft for various different internal tools. And one ask that came up, let's say you have like 100 or 200 notebooks. Oftentimes you would want to, maybe 5 or 10 of those notebooks would take the same inputs or share some output schemas. Most good APIs do that. You'd have a set of APIs that all take the same input, and I wanted to enable that same experience here. So what I've done, I've actually taken a notebook from GitHub, from this guy's GitHub repository, and so this notebook, it takes a Python class as input. I mean, the first line of the notebook, it actually instantiates this portfolio Python class. This notebook does some stock analysis. And this Python class, it's got a start date, end date, and some holdings. So what I can do with Jupyrest is I can provide this model as part of my application. Say, okay, this Python class, we're going to give it a name called portfolio. And then in my config.json, I can reference this named model in my schema. So now it lets me reuse a Python class among many of my notebook APIs. Okay, so with that, what do we get? So first off, when we get the notebook schemas here from the client perspective, this is still standard JSON schema. We can see the definitions here. That portfolio class is full JSON schema, like all the different properties here and their proper types. The client doesn't need to know anything about how this is implemented. Now, if I execute this notebook, so what I'm doing here is I'm sending effectively JSON. I mean, this is a Python dict, but you can imagine I'm sending straight JSON, and it's JSON that adheres to that Python class's schema. So what Jupyrest will do is it's smart enough to recognize that, hey, this portfolio key here is actually supposed to reference a Python class. And what it'll do is actually convert that this JSON input into Python code inside the notebook. So once this finishes, there we go. So let me open the HTML. So you see my notebook, the way it parameterized it is actually it wrote Python code inside my notebook. So this notebook does not need to know that it was actually being used as a REST API at all. This notebook only knows Python, and it only needs to know Python. So just to recap, what Jupyrest did, we sent it JSON. Jupyrest said, okay, you are referencing a Python object in your schema, and this Python object is this class. So Jupyrest says, okay, I will create some code that instantiates that class with the parameters that you put into the notebook. So now, as a notebook developer, I'm just working with straight Python objects. There's no JSON serialization. There's no, mapping between, nothing like that. It's just Python code through and through. So you can imagine you can create a very large API space and really make it modular using just Python. and notebooks, of course. So we see this notebook. This does a whole bunch of stock stuff. Maybe one of you in the audience can teach me what these mean later on. But you can see here, this notebook is a little bit more involved. It's got some basic graphs and charts here. And just like the other ones I showed, this notebook is calling save output. So that means, in addition to the HTML and all the code generation, I'm able to get the JSON output from this notebook. So I can still treat this notebook like a REST API, but then I get this wonderful execution log of what my notebook function actually did. So that's it for the demo. Let me talk about a few things, in terms of how you might want to use this library for your own cases, just from my own learnings using it at Microsoft. So let's talk about when you should not use Jupyrest first. So the big category of things here is really performance critical services. If you're trying to build a web service that needs to be really low latency or high throughput, don't do this. Notebooks take a while to execute. They may take, up to a minute. The API itself is asynchronous by default. So if you need that, there's many other ways to deploy high-performance Python web applications. This is not one of those ways. However, there are still a lot of things you could use Jupyrest for. And the primary use case at Microsoft that we use it for is for incident response automation. So a lot of engineers, we have this thing called on-call, where we basically have to sleep next to our phones and our laptops for maybe a week or a day, and we have to respond whenever we hear a notification. And it's super annoying, nobody likes it, but the customers want it, and so we do it. The thing is that there's all these people trying to figure out how can we automate on-call, how can we make things simpler so we can all sleep like Jupy up there. So what I implemented at my company is using Jupyrest to automate our runbooks. So anytime an incident is created, we have a notebook associated with that incident that will be automatically executed with the parameters of the incident. So that notebook can do all the diagnostics. It can show charts and graphs, run database queries, even SSH into nodes. You can automate pretty much anything you want to automate that you can do in Python. And what this means is our engineers, including myself, it's a lot fewer things we have to do manually. It really puts a lot of structure around our automation. And it's all Jupyter notebooks, and who doesn't like writing Jupyter notebooks? That's all we have to deal with here. So there are some other use cases. Generally, any kind of automation you can think of, this might be a good use case. So things like data science workflows, custom dashboards, think about it like a Jupyter notebook with parameters. If you display all the charts in your notebook, you don't really need a dashboarding framework anymore. You can generate custom dashboards for every kind of question you're trying to answer and put it all in notebooks. You don't need to learn any kind of dashboarding framework, nothing like that. There's enough Python graphing libraries out there. And any kind of reporting that you need, automating just general reports, this is also a great way to do it. Jupyter notebooks can be easily converted into PDFs or LaTeX or some other format like that. So the other use case is getting a handle on this ever-growing scripts directory that I know some of you might have in your code bases. There's a bunch of Python files with random names that nobody really knows. So maybe the guy who wrote it left 2 years ago and you don't know what the heck's going on. So if you just want to put some structure around your scripts, this might be a good way of doing it and getting some maintainability there. So yeah, that's pretty much all I had for my talk today. Like I said, all of this is open source under MIT license. We got a website up as well. And LinkedIn is social media for me, so if you want to connect with me and chat about this later, please add me and I'd be happy to talk. And yeah, thank you all for coming to my talk today. It's been really fun.
Thanks. Any question can come over here to the mic.
So this looks really cool. It's a great talk. The one thing that has me a little bit nervous is that JSON file and having to maintain that. It seems like some of that could be generated from the function definitions that you have in the notebooks. Have you ever given thought to some way to sort of ease the burden of maintaining that file that dictates the interface?
Yeah, so this JSON file, you're saying whether we can auto-generate this based on the notebook itself. I see. Yeah, that really hasn't come up. I mean, one way you can think of the auto generation is how I showed the Python classes. Like if you put all your schemas in as Python code and just reference them in these configuration files, it really makes these files a lot smaller, and then you're just dealing with Python code. The other thing is Jupyter supports multiple languages, so C#, R. I'm not talking about that here because this is PyCon, but this gives us a language agnostic way of defining these schemas. So if you wanted a notebook in a different language, you could still do that. Thanks for the question.
Okay, thank you. So is it possible to include interactive widget right now?
Yeah, great question. So like I showed in the demo, when you get that HTML file, that is a static HTML file. And if you need any interactivity that requires a running Python kernel in the back, that won't work. But libraries like Plotly and even HoloViz, if you are fine with including all the data in the notebook itself, then you can get interactivity with those graphs as long as the data is in the notebook. It does make the notebook bigger, but we store these on blob storage, which is pretty cheap. And but interactivity that requires a real kernel, that won't work. You can of course run that on your laptop, but that won't work in this scenario.
Hi, thanks for the talk. Could you talk a little bit about practically deploying this? So you mentioned on one of the very early slides, this fits really well with sort of like a serverless deployment. How do you deploy it in practice? Is this literally just a web server that runs somewhere? And then how do you route different notebooks? Like what does that mechanism look like?
Yeah, good question. So the way, and the documentation will go a little bit more into this, but you can think of this, we can generate a Azure Functions application using like a directory of notebooks. So we can generate if you're running locally, we can generate a fast API just running locally, or we can generate an Azure Functions application. So in that case, we'd have a front-end worker with a queue for executing the notebooks, and then like a set of other worker nodes that are processing the notebooks. So that's sort of how we do it. We consider all those JSON files and your notebooks itself as your application definition, and then we generate the deployments for whatever environments you want to have. A lot of serverless platforms run well with fast API, so that alone can get you a lot of mileage, but on Azure we use Azure Functions.
More questions? No? Okay, thank you for the talk.
All right, thanks everyone.